Draw the truth table for the logic circuit shown in the figure below. From our figure, we can see A and B, two inputs, and is connected to an OR gate. So our output will be A or B. A or B will be taken as an input for our AND gate. So we can see A or B and C as the inputs for our AND gate. So the output will be A or B and C. This will be our input for our NOT gate. The NOT gate is a unary operator, so it takes only one input. Our output will be the complement of A or B and C. This will be the input for our AND gate, and the other input is D. So the bubble symbol indicates that it's a NAND gate, not AND. So our final output will be the complement of A or B and C complement and D, since it's a NAND gate, the complement of the AND gate. Now let's quickly draw our truth table. So for 4 inputs, we are going to have 16 possibilities. The formula is 2 exponent n, where n is the number of inputs or variables. So we have 4 inputs here. 2 exponent 4 equals 16. So this is how we do it. We write 8 zeros and 8 ones for our input A. For our B, we write 4 zeros and 4 ones. 4 zeros again and 4 ones. For input C, we have 2 zeros followed by 2 ones. 2 zeros again followed by 2 ones. 2 zeros, 2 ones. 2 zeros, 2 ones. For input D, we write 0 followed by 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So we get to the. Now aside our inputs, let's write down the intermediary nodes. We have A or B. For the OR gates, it's 0 only when both inputs are 0. So A or B. We have, for the first 4 possibilities, both A and B are 0. So we will have 0 as our output. For the rest of the possibilities, we fill them with 1s because they are not both 0. Our next node is A or B and C. Our AND gate is 1 only when both inputs are 1. So let's look for situations where both inputs are 1 and output 1. Now we write 0 for the rest of the possibilities. Moving on to our next intermediary node. It's nothing but the negation of our previous node A or B and C. For the NOT gate, wherever we see 0, we change it to 1. Wherever we see 1, we change it to 0. Our zeros are changed to 1 and our ones are changed to 0. For our last intermediary node, let's divide it into 2. Let's do the AND before the NOT gate, since it's NAND. A or B and C complement and D. Our output is 1 only when both inputs are 1. We have few situations where both inputs are high. For the rest, we fill them with zeros. Now to our complements, we swap zeros with ones and ones with zeros. So this is our final solution. We can hide the intermediary nodes.